Hi everyone, today we're going to continue solving polynomial equations and we're going to pick up where we left off on day 1. So we're going to try to find the zeros for this polynomial and we're going to notice that the leading coefficient is 1. Remember that that's going to keep our Q value looking pretty nice. Our Q value is going to end up being 1. So let's go ahead and identify our constant as 24. And our lead coefficient as 1. So P is all the factors of our constant. Q are the factors of our leading coefficient, which is just 1. So that means that I can fill this in with a 1 and a 1. Now, if I take the factors of 24, I have 1 and 24, 2 and 12, 3 and 8, and then finally 4 and 6. And remember to be able to list all of the possible zeros, we have to take positives and negatives into consideration. We have to take every one of our p values into consideration. And for each of those p values, we have to place it over the q value. Since I only have one q value, 1, then that makes it a little bit nicer. So let's go ahead and start listing our zeros. So my first p value is 1, and I'm going to say positive or negative 1, and then I'm going to divide by q of 1. And then next, 2 over 1, and then 3 divided by 1. Next, I'll have 4 divided by 1, and that gets me down this first column, but now I need to go up the other direction and keep going. So positive or negative 6 over 1, positive or negative 8 over 1, plus or minus 12 over 1, and plus or minus 24 over 1. So those are all of my possible zeros. Remember that there are not going to be that many zeros. In fact, there will only be 3. How do I know that? By looking at my original polynomial. Whatever the degree is, the biggest exponent is going to be the number of zeros, the number of solutions, roots, x-intercepts. Remember that we use all of those terms to describe solving a polynomial and saying what x is equal to. We have, well, let's see, 8 numbers times 2, because positives and negatives, that makes 16 possibilities. So what we're going to do is look at the graph on Desmos and pick some reasonable numbers. And whenever I put this equation into Desmos, I see that I have negative 2, 3, and 4. So negative 2, 3, and 4. Let's go ahead and go back to our notes and put those numbers into step 2. Here we are in step 2, and by looking at the graph, we know that negative 2, 3, and 4 should be our zeros, but we need to prove it. So we will pick one of these and use synthetic division to prove that it's a solution. So we're going to try, let's do negative 2. So x equals negative 2. Negative 2. And I want to set up synthetic division. Remember, what I'm looking for is a remainder of 0. And I want to check my polynomial. I have a third power, second power, first power, no power. So I don't need to add any of those placeholder zeros this time. 1, negative 5, negative 2, and 24 are my coefficients. Remember that for synthetic division, you bring down the first number, multiply it by our house number, by our k value, and write the result underneath the next column. So 1 times negative 2 is negative 2, and then I add to get negative 7. Negative 7 times negative 2 is a positive 14, and I add to get 12. And finally, 12 times negative 2 is negative 24, and I add to get that 0 that I actually already expected. We're just confirming it algebraically now. So this is a yes, it is a solution. Remember that this is our remainder, the 0, followed by constant x and x squared. The other thing we want to remember is if our solution was negative 2, then our factor is the opposite. It's x plus 2 is equal to 0, and that is our factor. So whenever we write our newly factored equation, we want to be sure that we use that version with the positive 2. So let's go ahead and rewrite. I have the x plus 2 that I just found out was a factor by knowing that negative 2 was a solution. And then I want to go ahead and recombine all of my coefficients, constants, and variables here to make my second one. So I'm going to go ahead and say x squared minus 7x plus 12, and the whole thing is equal to 0. So we got that by doing our division step above. And so now we have what I would call a partially factored polynomial. X plus 2 is a linear factor because it has an x to the first power on it, and I know that I can't factor that any further. However, I see that I have a trinomial, 3 terms with an x squared. That's going to lead me to an x box. So let's go ahead and do an x box to solve this one and get the rest of the factors. So I am looking for factors that multiply to 12, remember it's our a times c value, and add to be negative 7. And because I'm adding to a negative while multiplying to a positive, I know that both of my factors have to be negative, and so I'm going to put a negative sign on everything. Negative 1, negative 12, negative 2, negative 6, negative 3, negative 4. And the ones that solve my puzzle and add to be negative 7 would be the negative 3 and negative 4. So I'll make a note of that here and go ahead and add negative 3x and negative 4x to my box. Remember that the rest of the box gets filled in with our front term and last term, x squared and a 12. And now we are going to look for greatest common factors along each row and down each column, just like we've done a lot of times before. X and negative 4. Remember again, negative here because I see a negative in the box right next to it. I have an x here and a negative 3, again with the negative 3 being because I see a negative here, I have to have a negative here. Now I can write these as my other factors. So I have the x plus 2 from above. Please don't forget about that one. X minus 3 and x minus 4, and it all still equals 0. All right, now I have all linear factors, and so I am ready to solve. So let's go ahead and make a note that we are going to solve now. I will set each piece, each factor equal to 0 and solve the little algebra equation that I have by moving the number from the left to the right. So I need to move the 2 by subtracting 2 from both sides, and x is equal to negative 2. I want to move the negative 3 by adding 3 to both sides. X equals 3. Add 4 to both sides for x equals 4. And these are my final solutions. Remember, we were expecting 3 solutions, and we actually already knew what those solutions should be, but we are confirming them algebraically using our factoring skills.